Hello everyone. This is the problem of GATE 2006. The problem is on pile foundation. As you can see in the figure, and the problem is like this. For the soil profile shown in figure below, the minimum number of precast concrete piles of 300 mm diameter required of safely carry the load for a given factor of safety of 2.5, assuming 100% efficiency for the pile group is equal to. So what is being asked in this problem is number of piles, the minimum number of piles for the soil profile shown below, the minimum number of precast concrete piles. So minimum number of let the minimum number of piles required equal to capital L. So to safely carry the load of a load for a given factor of safety. So factor of safety is given here 2.5, and the load which is applied on the pile cap is given here as 5000 kilonewton. So there is the safe load. The safe load is given to you as 5000 kilonewton. For a factor of safety 2.5, the ultimate load this group can carry, QUG, will be the safe load multiplied by factor of safety. So 5000 multiplied by 2.5, this becomes 12,500 kilonewton. So there is the ultimate load which this pile group can carry, that you have calculated. Now, in order to find out the minimum number, we know based on individual shear failure, QUG equal to number of piles required to carry this load multiplied by the ultimate load carrying capacity of a single pile into group efficiency factor eta G. Now in this problem, it is given that the efficiency of the pile group is 100%. So eta G as per this problem is 1, and QU of single pile can be calculated. So or we can write it, QUG is 12,500 kilonewton must be equal to number of piles, which we have to find it out, multiplied by this one, the ultimate load carrying capacity of a single pile will be alpha times Cu into pi d L plus 9 times Cu into pi by 4 diameter capital D square into 1. So this is equal to number of piles. Now alpha is given in the problem as 0.57, and Cu for the medium stiff clay where the frictional force is going to come into picture is given to you as 100 kilopascal into pi, and diameter of the pile is mentioned over here that the piles of 300 mm dia, that means 0.3 meter, and the length of the pile is shown in the figure as 10 meter. That's given in the problem. So the L is given as 10 meter plus 9 times Cu. Now this at the pile tip. So at the pile tip, it is a stiff clay. It is not medium stiff but a stiff clay, and the value of Cu increases from 100 to 150, and therefore here at the pile tip the value of Cu is given as 150. So take it 150 multiplied by pi into diameter 0.3 whole square divided by 4 into 1. So let us simplify it and calculate. So take your calculator, and I will take the calculator and calculate it. The 632.638. So I have calculated it. 632.638 kilonewton. So the value of the load carried by single pile is 632.638 kilonewton multiplied by 1. Therefore, required number of piles to carry this load of 12,500 will be 12,500 kilonewton divided by 632.638 kilonewton. So if you divide it, you will get the number of piles required. So 12,500 divided by, this is 19 point is equal to 19.758 piles. So total number of piles equal to, so you will have to provide 20 piles. That is the answer of this problem. So here in the question, the minimum number of precast concrete piles of 0.3 meter diameter required of safely carrying the load for a given factor of safety equal to 2.5 is coming out to be 20 piles. So if you provide 20 piles in a square pattern, you will be able 20 piles will be required, and pattern you will have to decide. You cannot have a square pattern. 4 by 4 equal to 16. So you will have to go for some different pattern, rectangular pattern or something like that. You can go it. So number of piles that is to be found out comes out to be 20 piles. So 20 piles will suffice. It will carry the load of safely this 5,000 kilonewton safe load and ultimate load of 12,500. Thank you very much.